And now the imaging of the heart, Steffen Petersen from Queen Mary University of London will describe the work of the cardiac imaging group.
What do I do to get it started? Up there. It's a great pleasure to speak to you. So I'll present this, what we do in the heart. You've heard a lot of the things already, so I'll keep those a little bit shorter. Just a slide of disclosures. I don't think they're relevant to this talk. In 10 minutes, I can't really go into all the detail, but there are a number of publications that I'll show you in this talk. If you've got an interest, you can download them. They're open source, they're freely available. So this one shows you the number of authors. There were lots of people involved in the planning of the imaging part of UK Biobank who are all listed as co-authors here. The work actually started about 8 years ago, so this has been a huge effort to get to this stage, and it's very exciting. This slide shows you a table where you have studies listed, prospective cohort studies, where heart imaging using MRI has had at least 1,000 participants. And you can see that there's not many rows. And what you can also see is that UK Biobank that have now already recruited 9,411, that was as of Friday, into the cohort, that we are already the largest prospective study with cardiac imaging, cardiac MRI, and in particular exciting is not only the scale, but it's also that we actually have all these other MRI techniques in the same study. So you can see that the Dallas Heart study was the largest study to have brain MRI, cardiac MRI, and body MRI in 3,000. So we already are triple that size. You've heard from the other talks that this obviously is part of a comprehensive imaging visit, which takes about 3.5 hours. The target is 100,000 participants of the original 500,000 cohort. For cardiac MR, I don't know, we negotiate slightly better than the lower body, the body fat imaging. We were allowed to do 20 minutes. We didn't quite get the 32 minutes that brain have, but we're quite happy to be in the middle. What was very clear is, given that this is not a clinical setting, that we would not use any medications like contrast agent or any stress medications that we might give in a clinical setting to detect, for example, why somebody might have chest pain, whether some of the coronary arteries are obstructed. So this is a completely safe and non-invasive test that we're doing. So these images are quite small, but I wanted to show in one slide what we're acquiring. And if you're interested, again, we've published this as a protocol that you can read all the technical details, what we're doing in this protocol. But if you focus on this image here, that shows you a 4-chamber view of the heart. So it shows all 4 chambers, left heart, right heart, and the 2 pre-chambers contracting. And from these, you can imagine that we can measure the size, the volume of the heart, the pumping function of the heart, how heavy the heart is, so the left ventricular mass. So these are just some of the measures we can look at. We can look at the pre-chamber size and function. We can look at the complex contraction and relaxation pattern of the heart. And we can even look into the myocardial tissue. We could detect fibrosis or scarring. And we can look at vascular function, so vessel stiffness, like aortic stiffness, we can look at. So this is the protocol, again, accessible for everybody to look at the details of the MRI protocol. Now, we are very lucky that the British Heart Foundation has given us a project grant to analyze the first 5,000 cardiac MR images manually. Now, cardiac imaging, cardiac MR, unfortunately doesn't have the tools that brain imaging currently has that allow you fully automated analysis. Tools are emerging, and I think UK Biobank is a fantastic resource that can be used to develop automated tools that are very reliable. But at the moment, we are developing in 2 core labs in Oxford, and where I work at Queen Mary University of London, we're analyzing the first 5,000 cardiac MR images. And this is what the team has done over the last 10 months. They've analyzed the first 5,000 scans for left ventricular volumes and right ventricular volumes and mass. So you can see these contours that have to be drawn throughout the entire heart. So it's very laborious, even though the tools are getting faster and faster, but it's a lot of manual work and expertise needed to do this. So what we also did is contour the pre-chambers of the heart, so the right atrium and the left atrium, to get function and the size of the atria. Now, we've basically done part of what we want to do in the first 5,000 people already. We have already, because the big picture is clearly that we want to analyze 100,000, and I don't think that any funder would give us money to do that manually in 100,000 people, nor would you find people who are actually willing to do that work. So we are working with experts across disciplines to basically develop tools using our resource that will help us analyze 100,000 images automatically, pretty robustly. And that really is a necessity, because otherwise we have lots of images, but we can't really take out the information that they contain. So this is a busy slide, and I'm not going to show you all of it. It just shows you that work is ongoing. We've analyzed a lot of the imaging-derived phenotypes already that the British Heart Foundation gave us some money. Just to show you, for example, what we can see here is with increasing decade of age, you can see that the heart, and this is the volume of the heart when it's relaxed, left ventricular end-diastolic volume index, becomes smaller with increasing age. And you can see that in men and in women. These are all the measures of the left atrium and right atrium in men and women again. And just to give you another sort of indication is that the atrial size is fairly stable across the age decades, both in men and women. But what you can see is that in women, the left atrium is larger than in men. So all of this information might become very interesting when you're studying, for example, the risk of stroke development, stroke. What we have already started doing, which will be clinically very useful, is to say, well, if you're a 51-year-old man, Caucasian, what sort of range for LV mass? So how heavy should your heart be? And we can basically provide normal ranges for the population with increasing age in men and in women. So normally you would fall within this sort of pink bracket here. Now, how robust are we with our manual measurements? Now, there's a little bit of subjectivity in how you measure, but we've been very robust in saying how we want them analyzed, the images, and what you can see is if the same observer analyzes the left heart twice, that you get correlation coefficients that are almost 1, and 1 is basically perfect agreement between the measurements. If you let two different people analyze them, they're still very good, but as expected, they're not quite as much in agreement as when the same person analyzes the images. And these are the first images that basically my team gave me last week, so they're really hot off the press, if you like. And what I wanted to show you there is that each data point here is a participant from UK Biobank, and we are unbelievably grateful for all participants, because this is just a resource that's so fantastic. So I'd like to thank all participants who are contributing to this. The second reason I want to show you this is that the data that we derive, for example, the left ventricular mass, seems to make sense. So we know that with increasing blood pressure, the heart has to pump more, so the mass goes up. So with increasing blood pressure, the heart mass becomes larger. And that is the case whether or not you're taking blood pressure medications or not. What you can see here, and I found that quite interesting, but we need to look into this a little bit more, is that the blood pressure doesn't seem to increase the LV mass as much when you are on blood pressure medications. And I'll show you another slide that has sort of almost like a little movie going. Again, you can see the systolic blood pressure on the x-axis and the LV mass index on the y-axis in female and in male. What you can see is that this relationship between systolic blood pressure and LV mass that we've seen earlier is still there. So larger blood pressure means larger LV mass, both in men and in women. What you can see is now we're going through the age decades. So we're getting older now, younger, older, older, older. What you can see is that this slope of relationship seems to be getting smaller in the elderly, the older you get. So these are just some first observations that we need to look into more, but it just illustrates sort of one example of what you can do. But there's obviously many, many more things you can do, and the exciting thing is that all of you in this room, you might have different ideas how you can use this fantastic resource. So with this, I'd like to summarize that this is the largest prospective study to date with imaging of the heart using MRI. And the analysis of heart images is a challenge, but UK Biobank provides a great opportunity to advance this field. Collaborations are already forming amongst national and international academics and industry. And certainly in the cardiac MRI field, in the heart imaging field, we can feel the enthusiasm of everybody. So I think the future is very bright for cardiac imaging. Thanks to UK Biobank, the resource. This shows some of the many important people to get this off the ground. There is actually, even in just this bullet point, there's about 20 people who advised us what we should do. And now there's an equally large number of people who are interested in how we can basically better tackle the automated analysis of cardiac images. And with this, I'd like to thank all UK Biobank participants again and the funders. Thank you very much.